Last hour, I told you that if an attacker knows which set the victim is using, and the attacker can do the prime and probe attack, then the attacker can find out if the victim is accessing data or not. If the victim is accessing data or running code, then the attacker will be slower. If the victim is not, the attacker will be faster. And priming is just putting the cache in a known state. And there are all sorts of decorations and variations. There is flush and reload. There is reload and refresh, and so on. This is a fantastic area of research. I don't have time to explain it this year. I'm really sorry. So now I want to show you one working attack, which is using cache attack. This is a work from 2007. And the device under test is a machine which is running RSA, sliding window, left to right, encryption. And what you see here are, if we look at the x-axis is the measurement done by the attacker. And the y-axis is the latency, the time it takes the attacker to probe its own array. Essentially, it's not exactly prime probe, but essentially to probe its own array. And one data structure that the attacker has collides with the square operation of the victim, and one of them collides with the multiply operation of the victim. So you remember RSA has square and multiply. So now let's turn on the shared whiteboard and also simultaneously zoom in a little. You can all play around with your cursors here. So can somebody please place your cursors at one position in time, one bit of the key where squaring did not occur, when there was no squaring. Let me get that to hand. Just put your cursors, don't have to scribble. Find one bit where there was no squaring. Okay, it's very interesting. Oh yeah, no, come back. Let me give you a hint, okay? If there was no squaring in this bit, it means that the attacker was able to keep all of his entries in the cache set. So if you have a round where there was no squaring, then the eviction of the square, the probing of the squaring data structure would be fast. So now I see Orel and Arseni and Omer, you're already going there, right? So all of the rounds where the victim did not do multiply, did not do square, I'm sorry. I need to do this again, okay. The attacker is always doing squaring, right? Every round it's doing square, but sometimes it's doing multiplying, sometimes it's not. So what you see here is that whenever there is no multiply, the eviction of the multiply is very, very fast. You don't see it. And if there is a multiply, then the eviction is slow and you see it. And if you see every round there is square, right? Every round there is square, but not every round there is multiply. So you see, we can only see, we can actually literally see the multiplies happen. So we see in every round there is a square, but only in some of the rounds there is a multiply. So you can just read out the bits of the key. Of course, now we can do something else to avoid this. This is actually an instruction cache. You can actually read out the bits of the RSA encryption this way. So I'm going to go back to my presentation. And now I want to motivate my discussion of Spectre with a little thought question. The attacks I showed you right now assumed an innocent victim and a malicious attacker. But there is another mode of side channel, which is called the covert channel. The covert channel means that the attacker and the victim are actually friends. They want to communicate, but they are not allowed to communicate. Why are they not allowed to communicate? Because one of them has a secret and is protected. There's some kind of isolation, some kind of firewall which is protecting that. They really want to communicate. And my question for you is, how can two processes use prime and probe to communicate? Okay, so there is a sender. No, we don't have an attacker and a victim now. They're both guilty. There is a sender. The sender has an array, and the receiver has another array. And now I want to communicate. I want to send something from the sender to the receiver. How can I do it using prime and probe? Let's say I want to send some data. What does the sender need to do? Okay, let's say I put the data inside the cache, but I can't. They're isolated. The receiver can't read the data from the cache. The receiver there is isolation, right? Okay, so Lidor is getting closer. I'm using the addresses as the bit of the message. How do I do that? How do I use the addresses? Okay, Alina is correct. I'm going to evict cache line. How do I do that? The state of the cache, indeed, of the cache line is there. So anybody else wants to share their thoughts? And then I'll summarize. I'm going to communicate between two processes using prime and probe. Okay. The receiver primes the cache. Then the sender evicts, right? And then what does the receiver do? And then, but let's go with Lidor's option. And then the receiver probes. Okay, so what I'm going to do now, to send data from the sender to the receiver, I'm going to be using multiple sets in the memory. So I'm going to use, let's say, this is a set, and 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 this is a set, right? So I'm going to, it's like a memory bus, indeed. So now if the sender wants to send, let's say I have here the numbers between, let's put it between 0 and 8. If the sender wants to send the number 3, it's going to access this piece of memory. It's going to access this piece of memory. It's going to evict something from set number 3. And now the attacker is going, the receiver is going to probe all of the 8 sets. So it finds out that this set is very, very fast. This set is very, very fast, and so on. But this set is going to be slow, and this one is fast, and so on. And this is how I can actually send data between two processes using prime and probe. So the sender is going to access one piece of the memory, and the receiver is going to check which set got slower using multiple probe. Yeah, there are lots of things which need to work before this is done. This is in theory, and the difference between theory and practice. But who wants me to explain this again? Who wants me to explain the covert channel again? How do I send data using prime and probe between the sender and the receiver? Because we need this for Spectre. Okay, so some people want me to explain it again, so I'm going to explain it once more. The sender and the receiver want to send data. The sender wants to send data to the receiver. They have individual areas of memory. The sender and the receiver agree on a bunch of sets of the cache, which are small pieces of the memory which collide with each other. There's competition for this memory. To send data, first of all, the receiver is going to prime the entire sets, all of these, let's say 8 sets. The receiver is going to prime them. The receiver is going to put them in a very well-known state where accesses are fast, because the receiver controls everything, and not in one set, in all of these sets at the same time. And now, to send data, the sender is going to evict one line out of one of these sets. And it's going to do this simply by accessing the memory. So the receiver, the sender is going to choose which one of the sets it's going to evict just by accessing memory. And now the sender has finished running, and the receiver is going to probe not one set, it's going to probe multiple sets. And then it's going to find out which one of these sets is slow. And the one which is slow is the one which the sender accessed. So Lidor is asking, how do I control which set am I writing? Again, I need to be able to reverse engineer the mapping strategy, which maps memory to cache sets. But now this is already, it's happening. That's it. We're in that place in history where it's already happened. Why can the sender evict the receiver sets? Lidor is asking me. Because the sender and the receiver, even though they're isolated, they use the same microarchitecture. The mapping strategy maps both the sender's and the receiver's lines into the same cache sets. They're using a shared resource. This is the idea. This is why microarchitectural attacks break boundaries. Okay?